Okay, to display things in binary, you have this void bin display unsigned char input, and it's going to take an 8-bit unsigned char in, and what it's going to do is it's going to process all 8 bits. That's why it's going from I equals 1 to I less than or equal to 8 plus I. Now it's going to start off with a mask of 8, 0. So let's just pick a number like AB. Now AB, if you remember AB, if we take AB here and mask that with 8, 0, AB starts with most significant at 1, and if you mask that with 8, 0, you're going to get 8, 0. I say if 8, 0, and you're going, what? Most people think that logic is either 1 or 0, and it's not. If we have 8, 0 here, it's going to do the if. Only if we have 0 as this result is it going to do the else part, which is going to print a 0. So if we have A, B, A is an 8, 0 will come out of this, so it's going to print a 1. Then it's going to take the mask and shift it to the right one, so 8, 0 is now going to become 4, 0. And it's going to take AB, it's going to end that with 4, 0. A is 1, 0, so it's going to be a 0 this time, so it's going to print out a 0. So this little function is really quite neat. It's going to continually print out 1s and 0s to convert our input value that's coming in here to a binary value and display it on the screen. Now you're going to need to run this program to be able to get your numbers in binary, hex, and decimal, and you're going to need that to fill in a chart that you've got on lab number 3. Okay, as we run our program on page 4, this is what we're going to get. It's going to say input a hex value from 00 to FF. Now the reason why it's asking for this is because we're scanning f%x, which is expecting a hex value. So if we pump in something like AB and hit enter, it's going to show us, let's slide over here so we can see how this is working. It's going to show us our value in decimal, hex, and binary. So %d is going to be 171. The number we typed in, the AB, is going to show up as uppercase hex because it's got a %X here, and it's going to be using this binary display function to actually show it in binary. So this is really quite neat. Now, as I said, you're going to have to run this a number of times to be able to get this to work properly and see that, yes, here's my hex number, here's what it is in binary, and if you want, you can also see it in decimal, but this is what you're going to need to fill in your chart. Now let's just get out of this, and again, I said before, we can do Control-C, which allows us to terminate from our program, and I'll just hit continue to get out. And one of the things, this is for doing unsigned char. Now what I'm going to do is I'm going to show you the difference between signed and unsigned just by putting in this. And what I'm going to do now is I'm going to now compile it again, and I'm going to run it. And this is going to be a little different. And this time if I put in, say, 8, 0, notice I get 8, 0 is minus 128, and there it is in binary. If I put in a number like FF, I'm going to get minus 1, FF, and here it is in binary. So we see that our numbers here are going to basically be sign interpretation, as you saw earlier on the sheet on page 3. So just changing signed to unsigned. Now to make this work, let me just Control-C out and show you one last thing. I'm just going to hit continue to get out. Is if you don't put this in, and this is the problem that you run into, if you don't put number ANDed with 0 XFF, what it's going to do is promote the char that you've got here to a 32-bit number, because that's the default in the compiler. So if you put this in, everything will display properly.